Assalamualaikum warahmatullahi wabarakatuh. Today, my group members and I will be presenting on the topic of cloud computing and big data. So let me start by introducing myself. My name is BINTI and I'll be presenting on the part of challenges of cloud computing relating to accounting.
My name is BINTI and I will present about the advantage, challenges and also the solution of big data.
My name is FAR661 and I'll be presenting about the cloud computing.
My name is binti Muhammad and I will present about the definition, types and evolution of big data.
Okay, first we must know what is cloud computing. Cloud computing is the delivery of computing services including servers, storage, database, networking, software analytics and intelligence over the internet. Normally, we only heard of people storing their data online. So basically, the cloud computing is storing our information in online platform. Okay. But what is cloud computing in accounting, or also known as cloud accounting? Okay, it is a utilization of cloud computing in internet to build a virtual accounting information system. Okay. Basically, it is about collecting and processing large volumes of financial data with the use of cloud computing. But we didn't realize that we use the cloud computing. For example, if you use an online service to send email, edit documents, watch movies or TV, or maybe listening to music, play games or store pictures and other files, it is likely that cloud computing is making it more easier and possible behind the scenes to do all these things. Okay, so before we have cloud computing, normally the workers or employee in a company only store their data through their computers, desktop or hard disk. But nowadays we have cloud computing, which we can only store our information through the internet, which is in online platforms such as Google Drive, storage, Dropbox or other platform. There are several different models or even types or services that have evolved to help offer the right solution for the needs of the user. There are three types of cloud computing. First is public, which is it is owned and operated by third-party cloud services providers. Second is private, which is it is used exclusively by a single business or organization. And lastly, is hybrid, which is combined with public and private clouds. Cloud computing offers many benefits to the users, either to the accountants of the company or to the clients. But I will only highlight three of the benefits. Okay, first, it will provide real-time information updating. Okay, before having cloud computing, the accountant must update the information whenever they are in the workplace. But by having cloud computing, they can update the financial information everywhere. The process of providing financial information is timelier and more efficient because the accountant is not only limited to update the financial information only in their office, but they can update it from anywhere as long as they have internet connection. Besides that, cloud computing also will give an access to more current and detailed business information by shifting from paper-based accounting report to real-time financial dashboards and insight. The clients can have the access not only when the report is done, but they can have a look on the process of providing the reports to check whether they already start their report or not. The second advantage of cloud computing is automatic data backup and restoration. Okay. Reputable cloud providers offer advanced security measures, including data encryption, secure access controls, and regular backups. This can often provide better security than traditional in-house solutions. By having cloud computing services, the accountant will use the online platform to store the financial data of their clients. It will offer more security than the traditional storing data method. Before having cloud computing, the accountant use either Microsoft Excel or Microsoft Word or maybe other application to store the financial data of their clients. The tendency of the data loss is high because of maybe the accountant forget to save the files, or maybe their computer is suddenly shut down, so the data is lost. But by having cloud computing, it will provide the auto data backup, and it will save the data from loss. The next advantages of cloud computing is accessibility to all accounting information. This is because cloud computing will allow the users to connect to the financial affairs from any location via the internet. For example, if suddenly the clients ask the accountant to share about the progress of their work while the accountants are outside of the office, the accountant can just share to the data storage, for example, in Google Drive about the progress. So they don't have to go back to their office to open the files and share to the clients. Besides that, cloud computing will give the access applications from outside providers over the internet. For example, Google Drive, Dropbox, and many more, not from company owned, which means we use the third party to use their service for storing data. Furthermore, cloud computing will provide the financial information quickly, and it can be accessed from wherever it is. Cloud computing makes it easy for all the users to access the data without the need to buy the software and install it on their computers. Because before having cloud computing, both the accountant and the clients must install the software on their maybe computers to enter the data. But by having cloud computing, they don't have to do that anymore, because we can enter the data or even update the data on the online data storage. So it will save money not only for the accountants but also to the clients, because they don't have to spend money on installing the software.
So we can see that the digitalization of accounting services has proved to be a necessity for the current period due to the technological advancement offered and that for the major shifts in the accounting profession. So, while cloud computing offers many advantages, for example, the flexibility, the accessibility, and also in terms of cost efficiency, the organization must carefully evaluate these challenges before making the decision to convert to cloud. So first, let's talk about the security threats that may happen. In cloud computing, the data can be accessed from anywhere via the internet, which introduces the risk, a high risk of security concerns. For example, although the client have access to their data, there's always risk that the service providers might misuse the data for illegal or unethical purposes. And the risk will become higher if, let's say, the third-party software solutions are introduced without the client's knowledge. Next, we must consider the legal and also compliance issues. Effective legal provisions is necessary to address the security concerns that is associated with cloud computing. So organizations need to ensure that their service providers comply with all the relevant regulations and also standards. Another significant challenge is the issues with data portability. So not all businesses is compatible with cloud computing, and most of their cloud computing software does not allow for data backups on the client computer. So it can lead to a severe data portability issues. For example, if the organization decides to change or switch to a different software. So without the ability to back up the data, the organization might face data loss, or they might incur additional costs in order to access their own data. So by understanding the challenges that I have said earlier, the organization can better leverage cloud computing in order to help them grow and enhance their business competitiveness, while also safeguarding their financial data. So next, there are some solutions that can be done to overcome these challenges. First is the government need to formulate or implement a comprehensive legal and regulatory frameworks. This includes to develop a strong data privacy or security laws to ensure a strong enforcement of cybercrime regulations. Next, ensuring that users are educated about the benefits and also safety measures of cloud computing is important. This is because providing assurance that cloud services can be used without compromising their security or their privacy concerns will foster a confidence in the user to use the cloud computing. Lastly, the government can leverage the cloud computing to expand its e-governance. So the government's active involvement has always been crucial in promoting cloud technology in its country. So for example, promoting the IT infrastructure or development, particularly in rural or semi-urban regions, because improving broadband penetration and investing in the necessary IT infrastructure will support the widespread of adoption of cloud computing throughout the country. So as we can see, there are few solutions that can be implemented. And by implementing these solutions, we can fully capitalize the benefits of cloud computing. And this will keep the country or our country in the path of cloud growth while also safeguarding the security and also privacy of critical information.
Now we move on to the definition of big data. Big data refers to large and complex datasets that are difficult to process using traditional data processing application. Data with many entries offer greater statistical power. Data with higher complexity lead to higher false discovery rate. When considering big data in context of financial statement, several specific characteristics of FAR661 is verified. Firstly, volume. Financial institutions generate many amounts of data daily from transaction, market customer interaction, and operational processes. It includes data from trading platform, banking transaction, and card usage, and more. Next is velocity. Financial data is generated and updated in real time. Stock market transaction, currency exchange rate, and banking transaction occur continuously, requiring rapid processing and analysis to extract timely insight. The third is value. Big data analytics in finance aim to uncover insights that improve decision making, risk management, fraud detection, and customer experience. Lastly, variety. Financial data comes in various formats, including type of big data that will further explain in the next slide. Integrating and analyzing these diverse data types is essential for comprehensive financial analysis. Big data can provide a company with all the necessary insight to develop new and innovative ideas for products or services, even their marketing campaigns. Move on to next part of big data is types of big data. As the internet age continues to grow, we can generate an incomprehensible amount of data every second. This data can be classified according to the following types, which are structured, semi-structured, and unstructured data. Structured data is highly organized type of data and has certain predefined organizational properties. It is presented in structure or tabular schema, making it easier to analyze and sort. A database of customer information will be one of the examples of structured data. Moreover, due to its predefined nature, each field is discrete and can be accessed separately or jointly along with the data from other fields. It also possible to collect data from various locations in the database quickly. Next, unstructured data enters information with no predefined conceptual definition, and it is not easily interpreted or analyzed by standard database or data models. Unstructured data account for the majority of big data and comprise information such as dates, number, and facts. Examples of big data include video and audio files, mobile activity, photos we uploaded on Facebook or Instagram, and videos that we watch on YouTube or any other platform contribute to the growing pile of unstructured data. Last but not least, semi-structured data is a hybrid of structured and unstructured data. This means that it inherits a few characteristics of structured data but nonetheless contains information that fails to have a definite structure and does not conform with relational database or formal structure of data models. For instance, JSON and XML are typical examples of semi-structured data. The history of big data can be traced back to the early days of computing, but the concept gained prominence and evolved significantly in recent decades. In the early days of computing, which is 1960 to 1980s, data storage and processing were limited by the capacity of mainframes, computers, databases such as IBM's information management system, and the relational database model introduced by H.F. Hood in 1970 laid the green groundwork structured data management. Next, the emergence of data warehousing and business intelligence system in 1990s allow organizations to store and analyze large volume of structured data. Technologies like online analytical processing and data mining gained popularity during this period. The advent of the internet and the growth of Web 2.0 in 2000s lead to an explosion of unstructured data, including social media, content, emails, and multimedia. Google's introduction of MapReduce in 2004 and the development of the Head-Up framework in 2005 by Yahoo engineers document cutting and Mike Caffarella marked a significant shift in processing large-scale distributed data. In 2008, Big Data turned coin. The term Big Data gained prominence when our media organized in the first Strata conference on Big Data. In 2011, Big Data was defined by the three V, which are volume, velocity, and variety. Big data technologies maturation happened in 2010, where Apache Hadoop became a popular open source framework for distributed storage and processing of big data. NoSQL database emerged as an alternative to traditional relational database, which will provide flexibility for handling diverse data types. Cloud computing platforms such as Amazon Web Service and Microsoft play a crucial role in providing scalable infrastructure for big data analytics. The integration of machine learning and advanced analytics with big data allow organizations to derive meaningful insight and prediction from large data sets. Technologies like Apache Spark, designed for in-memory data processing, gain popularity for faster analytics. Big data continues to evolve in 2020 with advancement in technology like Apache Flink for real-time stream processing and Kubernetes for continuous orchestration. The concept of the data centralized repository for storing structured and unstructured data at any scale gain.
Big data significantly benefits the accounting profession by transforming traditional practices and providing advanced tools for analysis, decision-making, and also reporting. Here are some key advantages of big data for accountants. The first one, enhanced financial analysis and reporting. Big data allows accountants to analyze large volumes of financial information more accurately and comprehensively. This enables detailed financial reporting and deeper insights into an organization's financial health, trends, and also anomalies. Next, improve audit efficiency and accuracy. With big data, auditors can perform continuous monitoring and automated data analysis. This helps in identifying discrepancies, fraud, or errors more efficiently than traditional auditing methods. It also enhances the accuracy and reliability of audit results. And the last one, predictive analytics for financial forecasting. Accountants can leverage big data to perform predictive analytics, providing better forecasts and more informed financial planning. This allows organizations to anticipate future financial challenges and opportunities, leading to more strategic decision-making. Next, I will move to the challenges of big data. Big data presents numerous opportunities for the accounting profession, but it also introduces various challenges that need to be addressed to fully harness its potential. Here are some of the main challenges and corresponding solutions. The first one is the data volume and complexity. The sheer volume of data and its complexity can be overwhelming, making it difficult to manage and analyze effectively. Accountants must deal with data from various sources and in different formats, which can complicate the analysis process. The second challenge is data quality and accuracy. Ensuring the quality and accuracy of data is critical in accounting. Inaccurate or incomplete data can lead to faulty financial analysis and decisions. Big data often includes unstructured or semi-structured data, which can be difficult to verify for accuracy. The third one, data security and privacy. Handling large volumes of sensitive financial data raises significant security and privacy concerns. Unauthorized access, data breaches, and compliance with data protection regulations are critical issues. The last one, skill gap and expertise. Accountants may lack the necessary skills and expertise to work with big data analytics tools and techniques. The integration of data science and analytics into accounting requires a new set of competencies that many professionals may not possess. Solution to the challenges of big data is the first one is implement robust data management system and tools designed to handle large data sets. Utilize data warehousing solutions and data lakes to store and organize vast amounts of data efficiently. Additionally, investing in advanced analytics software can help process and analyze complex data more efficiently. The next one, establish stringent data governance practices and employ data cleansing techniques to improve data quality, regularly audit data for accuracy and completeness, use automated tools to identify and correct data inconsistencies, and implement policies for data validation and verification. The third one, adopt strong data encryption practices and invest in cybersecurity measures to protect data from unauthorized access. Ensure compliance with relevant data protection regulation such as GDPR or CCPA. Implement access controls and audit trails to monitor and manage data usage securely. And the last one is provide training and professional development opportunities for accountants to learn big data analytics skills. Collaborate with data scientists and IT professionals to bridge the skill gap. Encourage certification programs and continuous learning to keep pace with advancement in big data technologies. That's all from us. Thank you.